All right, so this is a phase diagram. Remember that anything over here is going to be a solid, anything over here is going to be a liquid, and down here it would be a gas. Any data point in that section would be that state of matter. So if we have something over here, it's a solid. If we have something over here, that is a gas. If it crosses this line, like you keep the pressure the same, but you increase the temperature, then it's going to sublimate. Okay? And so that's what's happening there. When it goes from temperature A to temperature B, you are sublimating. If you went like this, from a solid to a liquid, you'd be melting. If you went the other way, you'd be freezing. Okay? All right. Here we have a reaction energy diagram. We have the reaction is taking place down here. We have energy here. The energy of the reactants start off here at R, and they go up as they gain activation energy. Once they have enough energy for the reaction to take place, the reaction takes place. And some of that energy gets released, and the products end up here at U. Okay? Now in this case, the products have more energy than the reactants started with. So that means they absorbed this amount of energy, and so this is a endothermic reaction. Okay? And this line here, from the starting energy up to the activation energy, that is how much energy is required. That is the activation energy for that reaction. That much energy must be supplied for it to take place. Now, a catalyst is a chemical that speeds up the reaction by lowering the activation energy. Okay, so the black line might represent the normal chemical equation. Okay, with a catalyst, it might look like that. Less activation energy is required. Okay, so make sure you know what a catalyst is and what it does. All right, in this we have a chemical equation. It's at equilibrium. I think I spelled that wrong. But anyway, it's at equilibrium. So the question is, if we heat it, if we add heat, okay, what's going to happen? Well, heat is a product. So by adding heat, I'm increasing the number of, or the products, I'm increasing the product. So it's going to shift towards the reactants and make more reactants until it's at equilibrium again. On the other hand, if I put it in the ice bath, that's the same thing as removing heat. So we're removing a product. And if we remove a product, it's going to shift the other way and make more products to replace what was removed. Okay? H2O, also a product. If I remove H2O, it's going to shift towards the products. It's going to want to replace what we removed. Okay? If we add carbon monoxide, that is a reactant. So if we have more, I think I have a mistake here. If I add carbon monoxide, I have more reactants. So it would shift towards the products to once again be at equilibrium. Okay? If we have something like potassium chloride, KCl, we have a metal and a nonmetal. So this is an ionic compound. Remember, the ic, the IC, means having to do with. So an ionic bond is a bond that has to do with ions. Right? When we put an ionic substance in water, okay, the water molecules pull them apart. This potassium is positive. Water has a positive end and a negative end. So some of the water molecules are going to pull this potassium ion away. And the chlorine ion is going to get pulled away by a different water molecule's positive end. Because of this, the ions stay ions in solution. That's why salt water conducts electricity better than fresh water. Okay? Dissociation is what we call this process. These ions are dissociating from one another, but they're still ions. All right, here we have a diagram. This is straight from your reference tables, which you will have on your final exam. Okay? Now, I'm recording. So. Okay, thank you. All right, so we have, it's going to go, for example, let's say we go from the 6th energy level to the 2nd energy level. Why is that not? Oh, it's going behind the thing. All right. Can I click on it? I am confused. Well, anyway. Okay. Sorry for the delay there. All right. All right, so if we go from the 6th to the 2nd energy level, then we're going to release this energy level here. And remember, the visible light spectrum is Roy G. Biv. Red, orange, yellow, green, indigo, and violet. So when you go from, for hydrogen at least, if you go from that 6th energy level down to the 1st, you're going to release this quanta of energy, and that's going to be represented by violet light. Okay? If we went from this 1, 2, 3, 4, 4th energy level down to the 1st energy level, okay, then we would release this amount of energy, and that would be released as UV radiation or UV light. Okay? And I think that's just about it. We did that, did that, did that. Know that if we're comparing iron and lead, okay, iron atoms have stronger bonds with each other compared to lead bonds. And so that's why it has a high melting point. Okay. And then we have one more thing real quick. Remember, if you had like an element that was 1s2, 2s2, 2p3, and 1s2 and 2s2 and 2p5. This is a smaller atom than this one. Maybe not a lot larger, but it is larger. It has more electrons in its energy level, so it's going to have a larger atomic radius. All right, there you go. And the reason you know that, this one has 1, 2, 3, 4, 5, 6, 7 electrons. This one has 1, 2, 3, 4, 9 electrons. So the more electrons it has, the bigger the electron cloud will be, the bigger the atom will be overall. The nucleus is still going to be super tiny, but still. All right, stay curious.